This will be our last lesson in Chapter 1. At this point, you can define basic chemistry terms. You were successful with conversions in Quiz 1-1. Expressing your quantities in the correct number of sig figs from Quiz 1-2. That, for some of you, needs a little bit of work, and you'll get your quizzes back today so we can address that. Last time, we classified matter, and we just did a brief little test there in your do now, which you seem to understand fully. And what we're going to talk about now are properties and changes of matter. So this will be our last lesson for this particular chapter, and you'll be tested next week, and we will go over that date at the end. So with properties and changes of matter, we're going to be talking about physical properties and chemical properties, as well as physical changes and chemical changes. You want to watch the little video first?
Yeah.
Okay. I did it the other way the other class, but I think it might be better to watch it first.
Physical properties of matter include melting point,
Let's see melting.
boiling point, color, density,
Which is more dense?
magnetism, crystalline shape, malleability, ductility, luster,
What does luster mean?
Shiny.
You got it. Shine.
and refractive index. The physical properties of matter can be observed without any change in the matter's chemical composition. Chemical properties, on the other hand, can be observed only when matter undergoes a chemical change. Here are some examples of chemical properties. Hydrogen peroxide decomposes easily into oxygen gas and water. Iron reacts with oxygen to form iron oxide. Sodium metal reacts with water to give off hydrogen gas. Sodium hydrogen carbonate, baking soda, reacts with acid to give off carbon dioxide gas. Lead nitrate reacts with potassium iodide to form a yellow precipitate of lead iodide. Red phosphorus can undergo combustion in air.
So what they stated in the video is pretty much everything that's in your notes. We'll go over the nitty-gritty and just some key words to help you solve any problem that might be a little tricky for you. So a property that you can measure without altering the substance permanently, that is altering its chemical nature, would be a physical property. So these are things that you can see with your eyes or measure very easily. For example, a person's height or the length of magnesium ribbon, the mass of the pennies from the first lab you did, the volume of the pennies by water displacement, the density, the color of a substance is a physical property. You can see that without altering the chemical nature of the substance. The texture, is it smooth, is it rough? They talked about luster or shine. Melting and boiling point can be measured without permanently altering the substance. If you have water, you can boil it and you can determine the boiling point using a thermometer. You would measure the temperature over a time interval of heating, and where the temperature is constant, you'd have the boiling point. Now, matter can undergo physical changes, and they will affect physical properties only. The key is that you have the same substance at the end. If you have water and you boil it, you still have water, it's just in the gaseous state. If you have a metal and you pound it, you still have that metal. With the lead, they showed you that it was malleable. You could bend it. Ductility, also, you can stretch it out into long wires, but you still have the same substance at the end. Now, all phase changes are physical changes. You can boil a substance, melt a substance. What does it mean to condense? When a substance condenses, what happens to it?
Changes from a gas to a liquid.
Exactly, it changes from a gas to a liquid. Vaporization, the opposite. What does subliming mean? What does sublime mean? Sublimation. Change in state from what to what? Go ahead, Stephen.
Gas to solid.
When dry ice sublimes,
Or solid to gas.
you got it. So when dry ice sublimes, it goes from solid to gas. But gas to solid would be another phase change. That's called deposition. And you see that, for example, with snowflakes. Not that we see them down in Florida, but up north, in that instance, you go from gas to the solid, the snowflake. Both are examples of physical change, but subliming is solid to gas directly, and dry ice, for example, has that ability. Freezing, etc. So ice melting to water is an example of a physical change. Other examples of physical changes: dissolving sugar in water. It's still sugar, and you still have water. It's just undergone a physical change. Pounding, pulling, cutting, etc. All physical changes. You have the same substance at the end. You just may have a different state of matter. Chemical properties are different. These are observed only when substances interact or when a substance decomposes, that is, it breaks down. For example, hydrogen peroxide in the video decomposes to water and oxygen gas. So decomposing would illustrate a chemical change. So chemical properties can be observed when the substances interact, and there are a lot of examples of evidence that show that a chemical change has occurred, and we'll look at some of those in a bit, and you'll be carrying out several experiments this year that illustrate them. Flammability. Let's say you get your quiz back and you don't like it. The quiz can be lit on fire. It can be flammable. That would be a chemical property. Neutralization. Probably not so much for you, maybe your parents or grandparents. Like I know with my daddy, he'll have an upset stomach because he probably ate something he shouldn't have, and he'll reach for the Tums. What's happening there is a neutralization reaction, and I'll illustrate it for you. It'll make more sense in a few months, but nonetheless I can show you. What you have in your stomach is acid, specifically hydrochloric acid. You don't have to write this. Tums, Rolaids, some of those other types of antacids are bases. And when these two substances react, you will get a salt, which is relatively neutral in nature, and water. This is a neutralization reaction, the reaction of an acid and a base. This would be like your Tums or Rolaids. So the base neutralizes the acid that's built up in your tummy, and it'll generate a substance that's far more neutral in nature. So neutralization is an example of a chemical property. Now, when one or more substances are changed into new substances, you have what's known as a chemical change. They are going to involve chemical reactions like the one I illustrated for you, and you will have changes in energy as well. Examples of chemical changes are fermenting. This is a process through which you make beer, wine, etc. Rusting, chemical change. You're going to generate a product with different properties than what you started with, a different property, a different substance. Combustion. You've actually seen this before. I can illustrate both of these for you. With rusting, and we'll go over these chemical reactions in just a minute, you have iron reacting with oxygen gas, and you generate iron 3 oxide, which is rust. Rusting is a chemical change. With combustion, there are many examples of it. The one that you're going to be the most familiar with will be the reaction of glucose, a 6-carbon sugar, reacting with oxygen gas. This is cellular respiration, and what are the products of that reaction? What gas do you exhale?
Carbon dioxide.
And what are some of you drinking at your desks?
Water.
There you go. That's a combustion type reaction. So combusting also is a chemical change. Now we said that chemical changes involve chemical reactions, and I've drawn a few out here for you. What happens here is you have elements reacting with compounds, or you could have 2 elements reacting together to generate products. So you're generating new substances that have properties different than what you started with. In the examples I've given you here, let's look first at this one. Glucose and oxygen are your starting material. They're present at the beginning. They will react. These are the reactants. Reactants are your starting material. They will react to form products. Products are what you generate at the end of the reaction. This is a chemical reaction. It shows the reactants on the left and the products on the right. The arrow here indicates yield or yields or reacts to form. The plus sign indicates a comma or and. So reactants are present at the beginning of the reaction. That's what you're looking for in blank A. Products are the substances that are generated or produced when the chemical reaction occurs. Questions here? If we look at this equation here, would these 2 substances be reactants or products? Reactants, because they're on the left side. So these are R for reactant. So the rust would be the product. All right? So if I gave you a chemical equation, you could label the pieces. Good. The other piece you saw in the video, and I've got a better, cooler video for you that illustrates a little bit more. There are many lines of evidence that a chemical change has occurred. You can see gas being evolved because you will see bubbling. Sometimes there will be an odor associated with the gas as well. A precipitate can form. When you mix two liquid solutions together and you get a solid, you've generated a precipitate, and you're going to be doing that in the lab the first or second quarter. You'll see the generation of a blue precipitate in the next little video. Evolution or absorption of heat. Sometimes when you mix things together and you're not even heating them, they still smoke. Heat's being released, or you can have heat absorption. You can see light sometimes from a chemical reaction. You also can get a color change in a reaction. You're going to see that in the next video. Now be very, very careful. Color is a physical property, but a color change is evidence that a chemical change has occurred. That's a tricky concept. Let's take a look at the following video. You have this in front of you, and you'll be able to see examples of this type of evidence.
Okay, this is the evidence of chemical change lab. We're going to start with 5 milliliters of copper sulfate solution. This is a blue solution. We have 5 mils of copper sulfate to
What color is that?
test tube.
Blue.
All right, and then for the first reaction, we're going to add to the copper sulfate 7.5 milliliters of sodium hydroxide.
So you're adding a base.
I'm just going to pour that in there.
What happened?
Notice the change.
It's purple.
Well, it's a blue, but
Kind of gelatinous
it's like gunky.
precipitate.
It's like snot.
So the whole thing turned into kind of a blue jelly apparently, but on close inspection, we find out there's still liquid in there. There's still water present.
Yeah, I'm going to zip here because he's going to look at it. Now he's going to heat it. So he's got it on a Bunsen burner. And watch.
Okay, we notice the change taking place here already as this heats up.
So you heated it, and what evidence do you have that you have a chemical change? It turned black. Color change.
You see a color change. With a blue solid turning to black.
He's going to heat it more.
Anymore, what we have is a black precipitate. Black or dark brown.
So when you get a solid from a liquid, you generate a precipitate.
We're going to take that out of the hot water bath now. Let it cool. Shut our burner off.
So he's going to play with it.
See if we can get a better look at this. Dark brown color. Okay, now for the third reaction, we're going to add 10 milliliters of diluted hydrochloric acid. This is 1.5 molar.
This is acid.
Sodium hydroxide was also 1.5 molar. And we're going to add this hydrochloric acid solution to a test tube. All right, now we need to mix it to get this reaction to happen completely. So I'm going to use a stopper to make it a little faster.
What happened?
See what's happening here. In just a minute or so, we have once again a nice clear blue
So you
solution.
have blue.
All right, so the black solid is gone. In just a few minutes of reaction with the hydrochloric acid.
All right, now he's going to put a metal in.
Last part of this experiment, last reaction, we're going to add a piece of aluminum wire.
Look at the color of aluminum, or think about aluminum foil.
See if you can see anything happening here.
Watch carefully. What's happening?
First thing we see are some bubbles forming.
See the bubbles?
The wire is bubbling.
All right, the evidence of a chemical reaction, and now look what
The other
happens
thing
to
we
the
notice is
wire.
that the wire is getting kind of a dark, gunky solid forming on it. And you can
All right, and let's see what that dark gunky solid is. Now he is going to touch it with his fingers, which you should never do.
And let's see if we can get a better look at it.
What does that look
The
like?
color there is kind of a reddish brown.
Like a reddish brown, like different metal, huh?
Reddish brown solid on there. And let's see what that stuff is. Just pull some of that brown solid off of there. Because what I'm going to do is shine it up. See if you can see the
What is it?
shine of the copper.
It's copper. So through a series of reactions, he generated new substances with different properties. And I can diagram that out for you. It's something you'll be able to do later this year. But there were many, many, many examples of different lines of evidence that a chemical change occurred. And you could see the bubbling, the precipitate formation, the color change. You didn't really see either of those, but you saw those in the previous video. So those are all examples that a chemical change has occurred, evidence that a chemical change has occurred, and you'll be looking for those lines of evidence when you do your labs. An example of a chemical reaction is shown here. Iron and oxygen would be reactants or products. Reactants, and iron 3 oxide would be products. So this is rust, and you'll learn how to name these this year. What you also can see in some reactions is that heat or energy can be released or absorbed. When you look at the combustion of glucose in a reaction known as cellular respiration, you will see that energy is listed on the product side of the reaction. When energy is on the product side, energy is being released, and this reaction is exothermic. You'll learn later in the year, in the fourth 9 weeks, that the delta H, the change in enthalpy, will be negative in an exothermic reaction. For right now, all I would want you to recognize, if energy is on the right side of the equation as if it were exiting, you have an exothermic reaction. In contrast, if energy is on the left side of the equation, you have an endothermic reaction, where delta H for the reaction is positive, and you can see the energy is on the left side of the equation. The last thing I want to mention in this chapter, although you won't be tested on it, is when you're considering mass, volume, length, density, specific heat, and other properties of matter, some of them do depend on how much matter you have. Some of them do not depend on how much matter you have. Extensive properties are those that do depend on the amount of substance, so mass, volume, length, etc. Intensive properties do not depend on how much matter you have. The density of copper will be 8.92 grams per cubic centimeter. The specific heat of water is 4.18 joules per gram degree Celsius. So some properties don't depend on how much matter you have, others do, but we'll talk more about that throughout the year. Introductory chapters can be very tricky because they are so general in nature, they don't cover the nitty-gritty. So in regard to what you might be asked, if I gave you an equation like this, I would expect that you could tell me that these two substances are reactants, that these two substances are products, energies on the right side indicating an exothermic reaction. I would expect you could tell me that water is a compound. So just some very basic questions. I would expect that if I said, okay, I had breakfast and I had a piece of toast, and on that piece of toast I melted butter. Is melting indicative of a chemical or a physical change? Physical, because it's a phase change. Those are the types of questions you might be asked. And what will really help you fully understand the difference between chemical and physical properties as well as chemical and physical changes will be the second classwork that I gave you. That's classwork 1-2. Yesterday you completed this part. You now can complete the rest of this. It'll probably take you about 5 to 7 minutes. So I want you to complete, and you may work in your productive groups, classwork 1-2. The other thing I would like you to work on, I'm not sure you'll finish it today. Period 1 really liked that POGLE activity, POGLE for Project Oriented Guided Inquiry Learning. The POGLE activity I gave you yesterday really went into classification of matter with molecules and atoms and compounds versus elements. So I'd like you to work on that packet as well. And that should help you solidify both concepts. Now with these concepts you can ask lots of little multiple choice questions. You won't be quizzed on these prior to the test. So when you go through the classwork, if you have any questions, please ask your group members, please ask me, whatever you need to be successful. Keep in mind the answer keys are in the back of the room as well as on Edline. This answer key I just completed, and I will get that one up to Edline as well so that you have it. Questions on the lesson or what you're being asked to do? Okay, tomorrow we will immediately get our lab started. Hang on. Questions here? You're good? Okay.